Hello, hello everyone. I think we are live right now, so I think we can get started. Um, so I'm doing this kind of thing where I have like what you call. Yesterday I stumbled upon this website called Project Euler. So this website I think has like maths problems that you can solve using programming. So yeah, so this is something people do as a recreational activity, so that they can get good with programming and stuff. So I'm giving myself like a bit of a challenge. So I'm going to spend about 1 hour and then take a small break and spend another 1 hour session to try and solve some problems in this website. So that's the plan for the today's stream. That's what I'm going to do. So, yeah. So I will write a small statement of what this stream is about. Right. So let me see. Okay. So the plan for today's stream is to solve as many problems as possible as possible. The So yeah, this is what we are going to do, so that anyone who joins knows what's going to happen in this today's stream. So yeah, that's what we are going to do right now. Okay, so let's see what we can do. Um, so I already have an account in this website, and I have like solved two problems out of the many problems that you can see here. So the idea is the once you go along these problems, once you solve these problems, it becomes more challenging as you go along. So that's the kind of the thing. And I'm in problem number 3 right now. So the problem 3 is find the largest prime factor. Um, so we are given this huge number and we have to find the largest prime factor of that number. So that's what we have to do right now. Yeah. So, yeah, so that's what we're going to do. Right. So I'm trying to stream daily. I'm trying to stream like at least 4 hours per day. Today I won't be able to do 4 hours, but you know, in the future I will be able to do 4 hours. So that's what I'm going to do. So yeah. So to solve this kind of a problem, I have a little bit of idea on what we need to do. So we have to divide this number by prime numbers. So yeah, so if I can open up the terminal, you will see what I mean, right? If I open up Python 3 and let's say n is equal to this example value that we got here. If we divide it by 2, which is a prime number, we get a decimal value. So we can't divide it by 2, so we can divide it by 3. Mm, so we can see we can't divide it by 3 as well. So we have to divide it by 5, which is the next prime number, and we get a value that's divisible by 5. Okay. Then we have to divide it again by another number. So like 7. So yeah, 7 works. Then we have to divide by 13, which is the next prime number. Because if you divide by So it's like we so n we divide it by 5, then n is this, then n is we divide it by 7, divided by 7, then n is this one, then we say n is we divide by 13, then n is 29, then n is divided by 29, then n is 1. So we have to divide this number by prime numbers until it becomes 1, basically. So yeah, that's what we have to do. So I was thinking of creating a small class that will allow us to do this do this thing. So let's see. Okay, so I created a new file. Let's create like a class to do this thing. So yeah, we have to take some help from AI as well, since I don't remember all the syntax of C++, but I'm learning it. So so what I'm what I'm going to do is I'm going to create like a small class that will allow us to do this kind of operation. So the idea is to have a class that that has a number as one of its attribute. Let's call it n, and we can do a single operation on that class, which is like the next. You can call the next sort of divisor, and it will divide the value and give us the result until it reaches 1. So let's see. Oh, okay. Yeah. Okay. We have n, which is private. Then we have something public, which is like void. Next takes no arguments, so it's void. So something like this. Also, it needs a constructor. So this is where I need the AI help because I am not very familiar with the syntax at all. Okay. So what can we do? Okay, so I can use ChatGPT for this thing, right? I just copy this thing. I say I have a class. Can you help me write a construct that accepts a integer? Also, how to write the definition for function. So I prompt it like this. Let's see what it does. Okay, so the constructor also is public. Yeah, prime factor like that. And yeah, we need to store the something like this is the current device like so, and we do the implementation here. Factor, yeah, like that. Uh, so these are the default values that it will set itself to. So 2 is the yeah, 2 is the divisor that we have, the current divisor, and then it is the value. Then we have to implement the next function, which is prime factor next, takes no arguments. We do this. We can do something like this. Next, like that, and we can see if it compiles or not. So yeah. So let's see if it compiles or not. Okay, so exit out of this. Okay, so here is the terminal. Let's just compile this thing. Um, oh, no. I saved this. Okay, let's try to compile it. From Euler. Okay. Oh, okay. Let me call it. Yeah, we have to define main. Let's do this. Okay, so it's compiling, right? Okay, let's see. What we can do. Okay, so we can actually do prime factor. We have this number 39, and we can say it's that. Uh, can I do this? Yeah, yeah, we can do that, right? So, so this works. Yeah. So yeah. So what we're going to do is we're going to create a class that will allow us to find the prime factors of a given number. So that's what we're going to do. And yeah. So we have to implement this function. And so every time we call the next method, it actually, you know, finds the next prime factor of this number that we pass in. So once you do it a bunch of times, you will find all the prime factors of the number that you want. So that's the idea of what we're trying to do to solve this problem that we see. So I I have idea on what we can do. So since the current number and the current device are all in the class, we can like we can like see what we can do. So we have a state, so we can modify the state in the next function. Yeah, so let's see if n is divisible by the current divisor. So if that is true, so if it perfectly divides the number, that means we can go ahead and divide the number with this. Otherwise, what we can do is we can actually, the current thing we can increment by 1. Else we have to do a while loop, I think. While, so we increment it. Let's say, um, yeah, we have to do increment function. Okay, so while equals 0. So if we divide n by the current number, and if it's not equal to 0, then what we can do is we can try to increment the current value by 1, but we have to increment it by, so the current value should always be an even number, so then only it works. So if current is equal to 2, that means current is equal to 3, otherwise current is equal to, we increment by 2. So this will work, I think. So then we, yeah, then we find a value that's divisible by the current number, and then we do that like so, and we divide it. Yeah. So if n is 1, that means we have basically reached the end. We can return like so. We can actually print what n is. Um, um, yeah. Yeah. So I want to print like what the current value. So I want to print the devices once we execute the next function, so the user can see like what are the prime factors. So okay, yeah. So what we can do is we can do that, and like so, like that. Then we can do another one. We can do another one over here, like so. It will, yeah. So we are executing this function once. So technically it should print the first prime value. So it prints 5. So technically if we call it again, let's see what happens. Print 7. Okay. So if we do it a bunch of times, like so, see what happens. So it prints 5, 7, 13, and 29. And if we run it again, it won't print anything. Yeah, it won't print anything. So we can say like, let's say, then we print done. There's nothing more to factor out, let's say. So yeah, it says done here. So that means the program is working. So if you print one more time, um, like so, it says done. So it won't divide much more further. So basically, what we can do is we can create a method that, so this is a big number, right? So we can't have integers. Let's say we will put it like long here. The current can also be, yeah, the current can be like this, it doesn't matter. Um, and yeah, this is okay. Um, right. Right, we can, so to find the values, to find the prime factors, we have to have like a, I would say like a vector. A vector would be good, so we can like put in the values here. Okay, so how can we like create a vector in C++? So let's ask vectors, how to implement that. So let's see here. So we have to include the vector library like so, and then we have to create like a vector like that. Int. Actually, it's going to be long. Yeah, it's going to be int. That's fine. Then factors like so, and that's how we will implement the vectors, right? Uh, yeah, the factors are there. Mm, and what we can do is, so we can return false, and we can return true. Actually, return true here. Then this will be Boolean. False means every every factor is found. Uh, False means we have more factors to find. So that means I will remove this thing to make it Boolean, right? And then what we can do is we can actually like push back. Yeah, push back. That's the function we can use. We can say like yeah, we can say factors dot push back, and you push back the current device that you have. But actually, yeah, you don't need to call it in two places. I think you can do like factors push back like so, and that would work. Yeah, yep. So that would work, and we remove this thing. Then we do something like void run void. So this is just a run method, And if we implement that run method, it'll be like run. So the run method would just run the next function for you so that you don't need to manually do it till it's like while next we just do that. So basically, yeah, that's about it. So it will run until, so yeah, it will run itself until it finds all the factors. And then what you can do is you can like I we can like go through all the elements of the thing here and basically print out all the values, I think. So something like that. I'm not sure if it will work as I want it to, but we can give it a try and see what happens. So yeah, that's what I'm going to do. And also one thing I noticed is we don't need this duplication here. We can actually, yeah, we can actually remove it and actually paste it somewhere here. Yeah, like that. So I think this should be good. Mm. Oh yeah, fact. Yeah, this should be long now. Okay, so it prints all the things here. So I think it works. I think this thing works. So we can like say something like Boolean verbose, you know, so that we can control whether we print or not. So if then you do this thing, otherwise don't do that. So verbose. Okay, and then we can also do verbose here, verbose here, like that. We have to, and we will say like false or something. Yeah. So basically it works now. We have this kind of thing, and we can find the largest one. So this is the number that we have. So if I enter it here, 51475. So the largest prime factor is 6857. Okay, is that it? Yeah, yeah, we got it. So I thought like it will have like a lot of prime values, but I guess not. It only has three. So yeah, I think we solved the third problem. So let's say, yeah, we are solving the fourth one now. So the largest, whatever this is, I will search for this. So how to pronounce it? Pronunciation.
Palindrome.
So
Palindrome.
palindrome, right? Palindrome. So a palindrome number is the same both ways. The largest palindrome made from the product of two digit numbers is 91 times 99. Find the largest palindrome made from the product of two three-digit numbers. Okay. So basically if we brute force this, we have to go ahead and like find three digit numbers, like all the three digit numbers from 100 to 999 and loop over all of them and find palindrome numbers, right? So in C++, this is not that difficult. We can like simply do it. It won't take that much time. So like if I have a program like, okay, so we can define like min to be this, max to be like this thing, and yeah, those are all the, that's the bounds of the program. We can do like, we can loop over all of them, all of the combinations one by one. J is also going to be like this, and j is less than or equal to max, j plus plus, and then we can do something like, actually, we can use like the, we can use the standard input output for this one so that we have access to the printf function. What we can do is we can do something like this, and we can simply just do product like so, I times j, and then we have just I, j, and product like so, and this will be like, yeah, this will be, yeah, I think we can run it. Okay, let's see. We have problem 4. Okay, so basically we have to do that. So yeah, it takes some time. It takes some time. I think I think printing takes a lot of time, right? So printing will take like more time. See, yeah. So without printing, it's quite fast. So, and we get like this kind of thing, and we have to create like a function to find out if it's a palindrome or not. So that's what we have to do. So, so which means it reads both. Yeah, it reads the same both ways, right? Okay. So we have to check every number and see if they are like palindrome or not. So there are so many numbers and we have to check each and every one of them. So um, so it's going to be a bit tricky, but I think we can like do it. Um, so how yeah. So the easiest thing to do is to convert this product into a string and then check it. That would be the most easiest way to do it. So I will try that out first, how to convert an int to a string. Let's see. Okay. So we have this thing to a string. We can simply string now. So we can do something like that, right? And once we do that, what we can do is we can like, since we have indexes of the string, we can go ahead and like check to see if the given string is like a palindrome or not. The easiest way to do is to reverse the string and see if like how to reverse a string and see if it's the same. Right. What is the time complex? Okay, so the time complexity is a bit high, right? So yeah, so it's overfed. So the entire time complexity is something like this. Um, which is, one could say it's constant because none of the min and max bounds change. So yeah. Um, yeah, this is the simplest, so it is not that difficult. So so we have to create like a copy, like so, p1, p2, like that, and then we say okay. See if we can like print them Um, yeah, so let's see if we can solve this thing. We have to convert it into C strings. Uh, so there are so many so many steps that might make this not that efficient. So, but since it's C, it is quite fast. Um, okay, let's see. So we have all the numbers that are basically palindromes and the combinations, and still there are a lot of them. So we had to find the largest one, and the largest one is yeah. So we had to keep a track of that. So we can do something like largest 0 and see what's the largest one. So if product is greater than the largest one, then largest product. So we say something like that, but we are not interested in the product. We are actually interested in the multiples. So we have to say L1 into L2, we just define it and then we store them every time we encounter the largest one. So to do that, what we can do is we can L1. So L1 we can say something like L1 is I, L2 is J. The largest we update it to be the product. So something like that, and then once we exit the loops here, we can simply just print out everything. So we can say do something like this. L1, L2, the largest, and we can do this, comment that out. Okay, so we found the largest one. It's this number, and the multiples are these two things. So if we feed that, find, okay, so we have to enter this number here. Let's see if it's correct or not. Yeah, we solved that problem as well. So now we are going to solve the fifth problem. Um, so before I go any further, I will just commit all of these things. Okay. So this is the fifth problem. We have about 17 minutes left. So we solved about two problems right now, and let's see how we can solve the fifth problem. So 2520 is the smallest number that can be divided by each of the numbers from 1 to 10 without any remainder. What is the smallest positive number that is evenly divisible by all of the numbers from 1 to 20? So we have a few viewers, I think. Yeah. So hello everyone. So we are going to solve problems in the Project Euler site, and this is the fifth one that we have. So let's see. 200, 2520 is the smallest number that can be divided by each of the numbers from 1 to 10 without any remainder. What is the smallest positive number that is evenly divisible by all of the numbers from 1 to 20? Okay, so we have, so let's see. So if we go to like here, So we have 220. So it can be divided by 1, it can be divided by 2, 3, 4, 5. Like without a remainder, it can be divided, right? So, so we had, okay. So so it can be divided by all of the numbers from 1 to 10 evenly, and that is the smallest number that can be divided by each of the numbers from 1 to 10 evenly. Okay. So can it be divided by 11? So it can't be divided by 11, so we stop that. Okay. Um, so okay, so how do we do this? Yeah, again we can do brute force. Like we can start from somewhere and then we can like divide from 1 to 10 each number that we encounter and see if it's divisible by all of them, like, and yeah, then see if it's divisible by all of them. Again, most of these problems require like brute force, but obviously when we have to think of optimization as well at some point, but I think for these problems it's quite easy. So we can like go ahead with the naive brute force method. So so it's we can try it out first. So while we haven't found the answer yet, we have to do stuff till we find the answer. Um, so in the value we can say like it's 1. So 1 is there. So what we can do is we can divide it by all the numbers till 20 and see how far it goes, right? So we can do that. Um, and I think when you find like a number that isn't divisible, we just break out of the for loop and we try with a new number. So yeah, that's what we're going to do. Um, so if the value is divisible by, uh, yeah, if it's not divisible, then we just basically increment the everything and we break out of the loop. Um, we say found equal false. So if we found it, we can simply break out of the loop and yeah, we don't need to do this. We can say like true. Um, if found is true, then we can say value is value, and yeah, we can do something like this. So we start from 1 and we do this until like we found the value and then we exit the loop. So if we run this, I think it might work. We have to see. So let's see what happens. Problem 5. So yeah, we've we found the the smallest number that is divisible by all of them. So let's see how much time it took to do this. So it took about 2 seconds, I think. Yeah, 2 seconds to brute force our way into finding the answer. Yeah, that is correct. Okay, so yeah. So like when you have a language like C++, it's easy to brute force this. So if you code the same thing in like Python, it will take a long time to do that. But I think now um, we can't use brute force. Like once we go further down the line, we can't use brute force to solve this kind of problems. We have to be more critical on how our solution will be. Otherwise, it will take a lot of time, and we won't be able to like find the answer. So we have to exploit like certain mathematical properties when we solve the advanced problems here. So that means we have to study on like number theory and sort of things to, creatively solve these problems. So that's what I think. And yeah. So okay. So let's see what we can do. So we have about 9 minutes left on the clock. Um, so let's see. This is the square difference. This sum square difference problem number 6. Let's see like how we can solve this one. The sum of the squares of the first 10 natural numbers is this thing. So it's a series from 1 to 10. The square of the sum of the first 10 natural numbers is this. Hence, the difference between the sum of the squares of... okay, so this is a very simple problem, and it doesn't require much in terms of like programming. So it's like a for loop, I think. So we can we can solve that one as well. So let's see. We have right. Okay. So so it's going to be 1 to 100, right? So it's going to be 1 to 100. Like so. So we can have like the mean value, the mean value. So it's going to be a constant. We can say it's going to be 1, and the max value is going to be like 100. So we just need a for loop to like that is going from the min to the maximum, and yeah. So we just have to square these things. Okay, int sum1, int sum2. Let's say they are all 0. So okay, so sum1 is equal plus equal to I times I. Sum2 is plus equal I, just I. So yeah, so once we have that, then sum2 is just sum2 times itself, and we take the difference. So we take the difference of sum2 minus sum1, and we can just say like we can just print that out. So this thing. Okay, so that is the program, and if we like run it, it will be like So we get this value. I hope it's the downside. I'm not sure. Okay, that's the correct answer. Okay, so we solved this question as well. I think we can like solve, you know, like questions like out of order, but we can do it like in order. That's fine. Okay. So this is about prime numbers. So we have to find this prime number. So um, so I think there are like algorithms to find the prime number, like to check if a number is prime or not. What is the we can ask even ChatGPT like what are the sort of optimal algorithms to check if a number is a prime number. Then we can like loop through and then we can like find prime numbers. What is an optimal algorithm to find? Right. Sieve of okay, let's see this one. The sieve of is an ancient algorithm for finding all prime numbers up to a specific integer. So I can't pronounce this name, so I'm not going to say it. It works by creating a list of all numbers up to the limit and then iteratively marking the multiples of each prime number as composite, not prime. The numbers that remain unmarked are the prime numbers. So yeah. So let's see. So you list all the numbers uh, from 2 up to your desired limit, and then you start with 2, circle the first numbers and cross out the multiples. Okay. So yeah, we have to study this up before implementing it. I think there is a certain learning curve here. So I'm gonna see what we can do. Okay. Um, so this is like recommended one. So we can take a look into this one. Um, this one, yeah. So yeah, this will be good. Like a um, so n will be our length of the array. So in this case, so our length would be this thing right here. I think. Oh, it could be larger than that. Yeah, could be larger. Um, so yeah, so this could be an entire new stream. If you're going to do it like this, we have to implement it. Um, so we list like a lot of numbers and then we find out the largest one. So n will be a very large number. So let's see if we can get like a pseudocode for this thing and see what we can do. So code. So we initialize array of booleans, size is n plus 1. So 0 to n, we initialize all of them to be true. And if 0 and 1 are not prime, 0 and 1 are not prime, okay, so we say they are false. We know they are false. So is 2 to the square root of this thing. What we can do is we can say if p is true, that means mark multiples of p as not prime. So p is 2 from p squared and multiples. Step by p, okay. Right. So you step by p. Right. I got it. So you step by that and you wherever you land, you mark as not a prime number because there is multiple there. And then you append that to primes. Okay. So we can implement this sieve in C++. We can implement that right now. I think it won't take that much time. We can, yeah, we can try to do that. Um, yeah. Uh, from 2 to square root of n. Okay. If p is a prime number, then we do this thing. Um, okay. Um, okay, let's see. I think we can come up with a function to do this. So so we can come up with a function to do this. So a function would be like something like let's see. Let's see. Okay. So we have to create a function, right? Let's create a function then. Let's create a function. Yeah, let's call it sieve. It has n. Okay. Let's define like an array, like call this prime. Oh, yeah, it's going to be boolean of n, and for int I 0, I less than n, I plus plus, and we say is prime of I is equal to true, like so. And we are going to say prime 0 is false. So those are not prime numbers because everything is divisible by those things. So let's say we have for int I equal to I less than max, I say I plus plus, or we could say p. Yeah, we could say p. Let's call it p. Sure. So the max thing, I don't know, like let's keep it up for now. Let's say to do. So it's going to be square root of this thing. Square root of this thing. So let's just do that for now. Let's keep it. And yeah, let's see. And we have if is prime, P. So if P is a prime, so if P is not a prime, then we just continue this thing. Okay, if it's not a prime, we just continue the loop. We don't care about it. Okay. So if P is not a prime, we continue. Otherwise, we say multiple for int multiple equal P times P um, to n. So multiple less than n, multiple so multiple plus equal P. Uh, so so multiple is going to start from P times P. So till multiple is less than n, multiple. So let's call it m. Can't type. Yeah, let's call it m. So if is prime m, oh no, so we are going to just set it to false like that, and right, and we will just print it out. So point I equal to I less than n plus plus. If is prime I equal, yeah, if it's true, we just print it out. We just print out I. So we just do that. Yeah, so that is the function, and we have to just do this thing. So we have to include like C math, I think. So what are the flow at C math? Keyword. Okay. So we have functions for that. So we can do something like flow sqrt of n. So this should be a double, I think. Can it be? Can the argument convert? Okay, so it will convert that. So that's fine. So yeah, so this is the function, the sieve function. Right. So this is the stream function right now. And like if we provide it with like n, let's say we write a main function here. Let's say the sieve, if I call sieve with like, I don't know, 100 or something. Let's see what happens. Okay, so it listed out prime values. 2, yeah, all of these are prime numbers. So we implemented the sieve properly based on the pseudocode, and it worked first try. So that's great. So in this stream we implemented a function that could find out all the prime numbers within a given range based on a pseudocode we got from ChatGPT. So by using this sieve that we have, can we answer this question? That's the question. So let's see. The sixth prime number is 13. Okay, what's this prime number? Okay. So we have to like think of a way to like um we have to come up with a big number here Let's say like I don't know. About so what is this number? It's 10,001. Okay. 10,001. All right. Um, so you start with two. Um, could, um, so I could like do something like let's say so the first prime number. Yeah. So I was saying j is one, and we will like print j, and we just increment j by one, and we will do that. Let's see what happens. But yeah, yeah. So okay, we have to increment j only if it's a prime number. Otherwise, we have to keep j like that. Yeah. So the 10,001 prime number is okay. Let's see. Let's give it like int index something. Give it like 10,001. 10. Yeah, this is 10. No. Okay, 10,001, and index. Then we print it. Um. So, so it didn't work. Let's see why. Mm, mm, okay. Let's see. So it should work. 10,001, right? 10,001. Mm. Uh, how about if we let uh, because you're not incrementing it, right? So we have to do this. We have to increment it, but only print it if it's like yeah, only print it like that, and then we just do this. Okay, yeah. So it's this number. Yeah, that is correct. So we solved that problem as well. That problem we solved with implementing an algorithm. So I think now we need to like think of it that way. Like when we are going along with hard problems, we have to think of like how to implement it with using algorithms. So yeah, um, so that's it for today's stream. I'm going to continue solving these problems. Like this is a good way to like learn about a language, like try to be comfortable with the language. So I'm trying to get comfortable with writing in C++ as much as possible. So I'm going to continuing solving these problems in this stream, continuing to stream as much as possible. Today was the first one. I'm going to, yeah. So I'm going to stick to a schedule and I'm going to do like at least 4 hours of a stream per time. And yeah, so I hope you guys have a great afternoon and I hope you guys join in for the next time we have another stream. So yeah, so if you guys haven't yet checked out this site, I encourage you guys to do that. I think it's quite fun and you get to learn about maths as well as you get to learn about programming as well at the same time. So with that said, I would wish you all a great evening, a great night, and yeah, I will catch you guys up in the next stream. So yeah, peace out, take care, bye.